Hello everyone, welcome back to Advent of Code 2020. We're going to be doing day 15 here, day 15. Rambunctious Recitation. You catch the airport shuttle and try to book a new flight to your vacation island. Due to the storm, all direct flights have been cancelled, but a route is available to get around the storm. You take it. While you wait for your flight, you decide to check in with the elves back at the North Pole. They're playing a memory game and are ever so excited to explain the rules. In this game, the players take turns saying numbers. They begin by taking turns reading from a list of starting numbers. Then, each turn consists of considering the most recently spoken number. If that was the first time the number had been spoken, the current player says 0. Otherwise, the number has been spoken before. The current player announces how many turns apart the number is from when it was previously spoken. So, blah, 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 blah. They have some examples. You first say 0, that's the first number. Second is 3. Third is 6, because that's the starting list. And then you say, 6 was last spoken. That was the first time it was spoken, so you say 0. Then, of course, the last number said was 0. And, that was said before on turn 1 and then turn 4. So the difference is 3. And then you keep going like that forever. The question is, what will be the 2020th number spoken? Now, this is, I think, relatively simple to write an algorithm to just simulate this process. And I have no doubt that we would get to 2020 very quickly. What I'm worried about is, like, what's part 2 gonna be? Because it's gonna use the same input. It might change the rules, I guess. But I feel like more likely is that it'll say, what's the 5 millionth number spoken? Or the 10 trillionth number, or something actually unreasonable to simulate. Asking us to, like, have a deeper understanding of the rules and notice cycles or something like that, right? But I don't see any obvious cycles in the program. I don't think. So I'm hopeful that, like, part 2 will just be like, what's the 10 millionth number, to make sure you're using an efficient data structure to simulate, rather than making sure you're doing something other than simulate. Because I don't know how to do anything smarter. But anyway, let's get started over here. And confirm we got our input okay. Yes, very good. I mean, we could use data list split to split on comma, but, like, we have regexes anyway. I don't know. It's gonna be so simple with data list split, right? Let's just put that in the Cabal file and. Okay. Import data list split on. And this is then going to be map read split on comma, and that's like it, right? We'll just make our input be a list of int. Okay, and that compiles fine, right? Yes. So we won't need applicative do today, I think. And we're going to need data map, data int map, for reasons I will describe shortly. Oh, we probably want strict. Because what I imagine is, what data do we need in order to do the next step? And I think the main thing we need is a map from number to, like, when it was most recently spoken. So we want, like, game state, let's say, is game state of turn is an int, and most recent is an int also. call it turn count. And spoken map, let's say, is an int map of int. And I think that's all we need. And then we just need a function that steps a game state. So that seems simple enough. Step game state, step of game state tc, let's say. We'll call the most recent number n and the map m. Easy. Equals. Well, it's certainly going to be a new game state of. Then we'll increase the turn count by 1. And the most recent will be, we'll call it MR, the new most recent. And then we just need to update the map. M insert into, no, M insert wants the key and then the value and then the map. And the key, this is the tricky part, which I did think about this problem a bit before I got started for a couple minutes, because the transition between turns seems the trickiest, because we're kind of in this weird state where if we recorded the most recent number both here and in the map, what turn would we associate with it? Well, the most recent turn count, but that's not the current turn count. That's not what we need. We want to only update the spoken map once we have looked up when the most recent one was previously spoken, right? So we want to insert most recent here to be previous time spoken map, not spoken man. Where, and now we have to define a few things. Most recent is, or the instead of MR, let's call it like next or something. Next, oh, whatever, we'll put on a new line. So next, we need to look up the previous time, right? And that's going to be our next, isn't it? So previous time is m.find with default most recent, find with default 0, most recent spoken map. That's simple enough. Why errors? Probably this is fine. It's just like the way I'm using it is invalid somehow. Like this should be an int. Yeah. Interesting. I wonder why not having this here was causing it to infer weird types. Huh. What was it mad about? Spoken map? I don't know, it's a mystery. Anyway, I guess I'll put this in and I'll take it out once I'm done writing. The other thing we need is next. Wait, isn't next and previous time the same? Yeah, they're supposed to be the same. Because well, wait, no. We're looking at the most recent number to be spoken, let's say 5. And we want to say next, what was the last time 5 was spoken, which we're going to look up in the spoken map. We're going to look up 5 and get 0. And that's previous time makes no sense. It should be turn count. Yes. Which is okay, this most recent number we're now finally updating. We're now finally recording it having been spoken. And the time at which it was spoken was the number of turns that have elapsed. So if 3 turns have gone by, the last number spoken was spoken on turn 3. Yes. Makes sense. So I'm not using previous time at all, and this is just next. All right, now a bunch of things are wrong. That's more exciting. So it's in... Oh, I see. It's inferring the type from here. Yes, because that's a function that looks at a map. But I have already destructured the map here, so I should be saying n. Or perhaps call it most recent and explicitly shadow here. I don't love like the record syntax because it gives you these functions which I rarely want to use. I'd still rather destructure. I just want to have like labels for the fields to remind me what they are, you know? Okay, now what's it still mad about? M-insert. Most recent turn count spoken map. It expected an int map of int, but instead... Oh, yep, turn count is wrong as well. This should be TC. God, reusing these names caused me a lot of hardship. Or just having these names available at all turned like what would have been obvious variable not defined errors into confusing type mismatch errors using the global functions. Like, I wonder what I'm supposed to do about that? Do I just say int map int, and like put comments on them? I kind of hate that. And yes, we're shadowing, but that's sort of the point. And you know what? I'm gonna shadow the other one too. See if you can stop me. There you go. They're all shadowed. Take that. So let's do some quick testing here. Well, actually, before we can really write a test, we need a way to initialize a game state from an input, right? Initialize is a function from input game state. Initialize inputs equals m from list of actually, it's a little bit weird, isn't it? Because the way I've implemented this, if I say the initial state is like 1, 2, 3, for example, then when we start turn 4, I should expect 3 to not be in the list yet. Not be in the most recently spoken list, or the spoken map. Because if it were, it would be there with the timestamp. Well, I mean, I guess it would be okay if it were in there with the timestamp of 3. We want to pretend it's a 0, but if we wanted to, instead of making special logic in our init function, we could maybe make step a little less confusing, but just has slightly more branching code in it, where we say if the time it was most recently spoken was just now. No, that sucks, because then that only helps for the very first number you look at. Like, how good is that, right? I think it would be better to have that in the initial code. So what we're going to do, nums, let's say, oops, we were writing this function here. We called it inputs, which is fine. And a from list of zip starting with 1, the turn number, init, I guess, to drop the last number. Yeah, okay, this is not efficient, but we're looking at a list of like size 8, so it's not a big deal. Game state of length inputs. Oh my gosh, we're doing 3 inefficient operations on inputs all at once. It's amazing. If only we had arrays instead of lists, huh? Last inputs and inputs. Does this type check at all? It actually does, believe it or not. I mean, this is kind of not very pleasant to read, but the idea is we're initializing 2 fields. Oh, you know what? I could use record syntax here, which might actually be nice for a change. Turn count equals length inputs. I never, ever use record syntax to define things, but it's actually really nice here. Curly there. And I guess, I don't know, does Haskell want us to put, like, is it typical Haskell style to put the closing brace here like you would for a list? And actually do something more like this? I mean, this is how tab completes it, so it's at least not totally insane. All right, well, we'll do that. So if I now say initialize of 1, 2, 3, we get this, which looks about right. 1 was most recently spoken on turn 1, 2 was most recently spoken on turn 2, and 3 was just this very moment spoken on turn 3. And so if we say to step of this, we say, it's now turn 4. The most recently spoken number was 0. And 3 was most recently spoken on turn 3. Okay, this looks about right. So let's just double check this against one of the examples they give us. We're given 0, 3, 6. And I guess we want to like map what's our function called? Map most recent over take, I don't know, 8 over iterate step, like so. So first we speak the number 6, which seems fine, and then a 0, and then a 0, and then a 4. Is that right? Yeah, and then a 0. No, that's not right. Wait, hang on. Zero and 3 and 6, and so we're getting the 6 just from it being the beginning of the list. The last number is 6. The fourth number spoken, which in our list is the second, should be 0. So what if we just like look at the details of the states? Why did it choose that? It said on turn 3, actually, you know what we could do? Just to make sure I'm not getting confused about what's happening when, I can put out the turn counts as well. So it says on turn 3, we speak 6, which is correct. On turn 4, we look at 6, and that was the first time it's spoken, so number 4 is 0. Number 5, though, we should be looking at 0. And it's been spoken before on turn 1. So we should have said 4 the previous turn minus 1 the first time it was spoken. So what went wrong here? Let's look at the state leading us to on turn 3 we recently spoke 6. So let's look at the end of turn 4. How are things looking? Are we like not up? Oh, I wonder if we're not updating quickly enough when you get the same number twice when you get 0 twice in a row, basically, or the same number twice in a row in general. Because at turn count 4, most recent was 0. Wait, do I have this indexed wrong? I do. I see. The tuples are backward. M insert. What order does it take the arguments in? The key and then the value. I mean, that looks right. What? Okay, well, let's try this with like numbers that are not specifically 1, 2, 3, right? 4, 5, 6. Oh, well. Yeah, so this is definitely wrong. We're looking, I don't know why it's wrong, though. we're saying insert keyed by most recent where most recent is like an int representing the number that was most recently spoken, and then we insert in the map the turn count, which is when it was spoken. That looks totally right. And then we look up in the map, not that it matters because the next computation is not the problem right now. The key, no, 0 first, the default, then the key, then the map. Yeah. Oh, hang on, I typed an X in there. So, I mean, I knew this was going to yield the same... Wait, what? Okay, okay. Yeah. So this is still wrong. Oh, did I just write my from list wrong? Oh. Yes, that's the problem. Because I want the times to be the values in the map, not the key. Okay. And now we get the most recent to be spoken was 4. And it's happening on turn 4. That seems fine. And again, the most recent was 0, but this time we look in the map and note that it was last spoken on turn 4. And we say that its most recent was 4. Well, I guess that is what I implemented, but it's not what I was meant to. I just was not really thinking about the problem when I wrote this. Indeed, I looked in the map and saw, there it is. It's 4. And let's just output that, but that's dumb. What we're supposed to do is this, if it exists, then if it's in the map, then subtract the value that was there from the current turn. Right? Gosh, I'm building kind of a Jenga tower of nonsense, I feel like. Kludge upon kludge in step, which, given that it's such a tiny function, feels bad. We have all these +1, and we're gonna have to put a -1 in here somewhere. And I think it's just because we're representing the data wrong in some way, but it's not obvious to me how. So here's the thing: we have to compute next in a more exciting way. So I think what we want is case m.lookup of most recent. Turns a maybe, yes, good. Spoken map of, and I mean, we could write this with maybe, and maybe I'll go back and do it, but for now, just pattern matching is sort of obvious. If it's not there, then we produce 0, right? Yes. Just previous. Then what we want is turn count minus previous? Is that all? Because our turn count, when we're considering what the 4th number to be spoken should be, let's say, we actually have that our turn count is 3, right? Yes. And therefore, if we find the most recent number was actually spoken on turn 3, and so we just take turn 3 and subtract the previous, that seems okay. Now we get, well, let's actually go back a step, haha, and just first say step initialize. We still get a 0. And then we get another 0. This all seems fine. And now we get a 1? Wait. 4, 1, 5, 2, 6, 3. That looks right. Hang on. Just let's like back up even more and just initialize for me, will you? And we have just 2 entries, 4, 1, and 5, 2. That makes sense. Then we say on, and what we most recently read out on turn 3 was 6. We look at the map, we find it wasn't there, and we say, okay, now it's time to output a 0 on turn 4. And when we then say, okay, the last, yeah, now we say, okay, the last spoken number was 0, and it's now turn 5. Wait a minute. The indexes are not right here, but yeah, I think that might be part of the problem. So we discover that 0 has been said previously 1 time. Oh, I just realized part of the reason I'm getting confusing numbers is because I'm not even using their test input. So let's just use 0, 3, 6. And but I think we're off by 1 here somewhere. God, how do I iterate? There we go. So on turn 3 we say 6, on turn 4 we say 0, on turn 5 we say 3, on turn 6 we say 3 again, on turn 7 we say 1. This is actually correct. This is what we were supposed to have done all along. We're not off by 1 anywhere. That's exciting. All right, that seems cool, I guess. Probably don't need lambda case either. So input is, or part 1 is most recent composed with head, composed with drop while, I mean, let's filter, right? I don't know. Filter equal 2020, the turn count, iterate step, initialize. It type checks. All right. So we're going to initialize based on the inputs. We'll step it forever until we get to turn 2020, and then we'll look at what the most recent number was. And since we just looked at the output of like that kind of iterate step process, we know that our turn counts are in fact synced up to what the puzzle definition expects. And we get 1238. I don't know. That could happen, sure. That's the right answer. Great. Day 15, part 1. Alright, what's up with part 2? Impressed, the elves issue a challenge. Determine the 30 millionth? Oh, that should be fine, right? We're using a good data structure. 30 million is not that big a number. It should just be easy, right? We'll say solve then is a function from int to input to int, and solve n equals this, and part 1 is solve 2020, part 2 is solve 30 million, right? I mean, it's possible this will take a long time, but I don't think so. 30 million is not a large number, and we have a good data structure. I mean, it'll take a little longer, don't get me wrong. Really? This is longer than I thought it would take, actually. And I know it's only a few seconds, but we have a data structure. How does InMap perform, right? It's like logarithmic time, I assume? Ah, there we go. It took a little longer than I thought, but nothing at all unreasonable. That's the right answer. Great. Okay. Well, that was maybe the easiest part 2 we've had so far. Day 15, part 2. Yeah, I mean, obviously a pretty simple diff, right? We could have made it smaller, of course, if we'd been willing to repeat this and not factor it out. But yeah, I don't know. Like, you could do better, I assume, with Could you? IntMap is a reasonably efficient data structure. What would be better? I mean, like a sparse vector, I guess, if your language supported it, but that's kind of what IntMap is, right? I think what we have is pretty cool. So I guess I'm done for today. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.